Okay, logarithmic functions. The important part here is that you understand when you see a logarithm what it is you're looking at and how you can relate that to an exponential, because we're pretty good with understanding what an exponential function looks like and how that works, but when we see a log we're often confused. So I want to relate the two so that you can see what's going on. So the way that you say this is log base A of x equals y. Log base A of x is equal to y. And what that means is if I take a, which is my little base here, if I take a and I raise it to the y power, I get x. So when you're trying to evaluate a log, you're saying, what exponent do I need to put on this base in order to get this number in here? And that is the answer to your logarithm. Okay? So I'm just going to go through this table using this and just convert from logarithmic form to exponential form and so forth. So log base 10 of 100,000 equals 5 says that if I take 10 to the 5th power, I get 100,000. Working the opposite way, I have 2 to the 3rd equals 8. So that means I can rewrite that as log base 2, so base stays base, log base 2 of 8 equals the exponent that I have to put on 2 in order to get 8. So log base 2 of 8 is equal to 3. Similar question here, we have log base 2, and now it's of 1/8. So what is the exponent that I need to put on 2 in order to get 1/8? And that is -3. 2 to the -3rd gives us 1/8. And then the last one, we have log base 5 of s equals r. This simply means that if I take 5 to the r power, I would get s. Okay, so we're going to use that fact to evaluate these. Often we want to think about them as in their exponential form in order to help us answer the logarithm. So we have log base 10 of 1,000. So what I want you to think about is 10 to what power is going to give you 1,000? Okay, and the answer to that would be 3. If I take 10 to the 3rd power, that means I'm going to have 3 zeros. That's 1,000. Okay, the next one, think about 2 to what power is equal to 32. 2 to what power is equal to 32. So what you could do is keep multiplying 2's together until you get to 32 and figure out how many of those 2's you just multiplied together if you don't know this, but the answer is 5. If I take 2 to the 5th power, 5 2's multiplied together, that gives us 32. Okay, the next two are pretty important in terms of what kind of answer you're going to get. So you're going to see these quite often, and we're going to have negatives involved, we're going to have fractions involved. You kind of need to know when to use each one. So what we have is log base 10 of 1/10. So this says 10 to some power is equal to 1/10. So anytime that you're trying to get to a fraction over here where it's 1 over something, my suggestion would be ignore this fraction. Just think about the number on the bottom and say 10 to what power gives me that thing. So 10 to what power gives me 10? Well, that would be the first power, right? But because it's on bottom, that means that a negative exponent was used in order to put that on the bottom. So for example, if this were 100 instead of 10, I would say 10 to what power equals 100? That would be 2, but because it's on the bottom, I'm then going to say -2. And then the next one we have 16 to what power is equal to 4. Now we're often not great about going from a bigger number down to a smaller number here. So my suggestion is don't worry about that. Go from the smaller number to the bigger number. So 4 to what power equals 16? That would be the second power, right? 4 squared is equal to 16. So if I'm trying to go the opposite way, you just make that into its reciprocal. 16 to the 1/2 power. Because 4 to the second power is equal to 16, 16 to the 1/2 power is equal to 4. And do remember that 1/2 power just means square root. But if you always just start with the smaller number to get to the bigger number, usually that will make sense. Just know that you need to do the reciprocal of that number, working the opposite way. So here we have some properties of logarithms. You can read through those, but I'm going to apply those here. If we have log base 5 of 1, again, you could know this property, which is this first one, or you could just think about it in terms of the way I was doing the ones up there. 5 to what power is equal to 1? And so the idea is anytime that this is 1 right here, the answer is going to be 0, because anything at all raised to the 0 power is going to equal 1. Okay, that's that first property. Log base 5 of 5 says 5 to what power is equal to 5. So anytime these two numbers are the same, the answer is going to be 1. That's the second property. Log base a of a is always going to be 1. And then log base 5 of 5 to the 8th. So this says 5 to what power is equal to 5 to the 8th. And the answer there then is obviously 8. And that is this property right here that says if I have a power of that base as inside of my log here, that it's just going to be, the answer is going to be whatever that exponent is on that number. So pretty easy there, but again, if you just think of those the same way I did those should all make sense. The last thing on here is what's called the common logarithm. Anytime that you just see log base x, there is an understood base 10 there. Okay, there is an understood base 10. Know that, because you're going to need to use that any time that there is not a number there, kind of like when there's a square root and there's not something on the ledge, it's an understood 2 because we're doing a square root. Anytime you just see log base x, log of x, the understood base for that is 10.